Okay, so we have a couple of quiz questions. Very straightforward. And I've observed that people who did the homework either got it or came real close, okay? People who started the homework and didn't have time to finish it or whatever, or didn't do it at all, didn't know what to do, okay? And what to do is very simple. We explained it last time. You probably want to review the video from last time, or look at the videos where Open Math explains the logic of this. Now, I'll explain the logic now, so maybe you don't need to look back if you understand what I say or review what I'm saying, okay? But you want to get this. So, how can the absolute value of the number be bigger than 4? Well, we drew it out last time. We said, okay, all these numbers bigger than 4, the absolute value is certainly bigger than 4, right? All the numbers to the right of 4 on the number line, we use the little red X's, okay? And I'm not sure the red X's corresponding to the numbers are included in the word. I don't remember which way that inequality went, but you get the idea. You remember that picture. You had a range of numbers that satisfied it, the range of numbers that didn't, or vice versa. Okay. If X is like 50, is this true? Well, yeah, you get 55, absolute value of 55 is greater than 4, right? What if X is negative 50? Does it satisfy? Sure does, because you get negative 45, and the absolute value of negative 45 is 45. It's bigger than 4. So if it's a big positive number or a big negative number, what's inside here is a big positive number or a big negative number. The result's going to be bigger than 4, right? Well, it comes down then to saying that, hey, you have absolute value of X plus 5 greater than 4. Now, I ask if you do this. You break it into 2 equations. What's that? Okay, that's a Monimeter report. It's actually almost in the process. The message that formed itself in my brain, but who knows if I would have actually done it. Some sort of mind. Okay. So we have, and that little pause wasn't for questions, just asking me to close the door because the video that's playing next door is distracting or something. Okay. I've learned to tune it out, so try to be aware of that. Okay. It's not excessively loud, but still don't be distracted. Okay. So what we said again is that this is going to be true if whatever's in parentheses is greater than 4. Not parentheses. Whatever's between the absolute values. Good. This number is bigger than 4. It's absolute values, right? Now, whatever X is, you're going to get a number in here. And if that number is less than negative 4, the absolute value is still going to be greater than 4. So you want to understand the logic of this. Just think about what's going to happen here. Okay, if it's bigger than 4, that's going to work. So there it is. If it's less than negative 4, there it is. Now, one person, not the names, did the negative of this is greater than 4. Okay, and that's correct, but it's a little more involved and a little harder to remember. But that was, an insightful way to do it. Okay, I recommend you just go with the idea that if the absolute value is greater than something, then either what's inside the absolute value is greater than that number, or it's negative, or whatever's in here is less than the negative of that number. Okay, because that makes it clear. And you want to think about that every time you do. You don't want to just do these things mechanically. You want to think about why these rules work. Otherwise, you're more likely to forget the rules. Okay? Okay, so the rest of it's really simple. And I'm not going to take the time to write out the steps because everybody is really good about writing out steps. Okay? So I know you know how to fill these steps. You can subtract 5 from both sides and you get this. Okay, and it's equally easy over here. You subtract 5 from both sides, you get x less than -5. Now, what does that do? Here's your number line. Put -1 someplace and put 9 someplace. Oh, sorry. Put -9 here to the left of -1. Of course, -9 first to the left of -1. Okay, put the -1 here. And I hope everybody knows -9 is to the left of -1 on the double line. Start from 0 and you count through the negatives, -1, -2, -1, this way. So, number that looks bigger with a negative sign in front of it is actually less. Okay. There we have it. Now, you just say the number for x is greater than -1. Well, it can't be equal to -1, so you use the open dot. And it can be anything greater than -1. You know that if x is greater than -1, x plus 5 is going to be greater than 4. Because x added to -1 gives you 4, right? If you use any number greater than -1, x plus 5 is going to be greater than 4. Make sure you understand that statement in the logic of it, okay? Understand the arithmetic well enough to understand what I just said. Okay, and then over here, x less than -9. It would be here. Then we can check. Pick a number less than -9. -10 would be a good one. Okay. Okay. That's a -10, you just plug it in, and you find that what you get is greater than 4, right? Want to convince yourself a little more, go to -11. You're going to get 6. And as you move through the negative numbers here, they keep getting your absolute value here is going to keep getting bigger and bigger. You might try to see that. Okay. Some of you probably will, some of you might not. But if you do this and check it, that's okay. Another check. X plus 5 is 6, and that's greater than 4, right? And then another check. Pick a number between -9 and -1. So you do that, you find that you get 1, that's not a solution. And it's not shaded. So that's okay. All right. So you check a number in this region, you check a number in this region, you check a number in this region. Works out. Then it's not an absolute check. You can't be absolutely sure, but it makes it gives your solution a lot of plausibility. Okay. You might also want to check what happens if x equals -1. Well, you're going to get 4. If x equals 9, you're going to get absolute value -4 is equal to 4. Okay, it's not greater than, but it's almost. Well, think about those things to understand the absolute value. Okay. Now we have the other question forever. Oh yeah, right there it is. Okay. Got this. That splits into 5x minus 3 less than or equal to 7. And I also said you want to put the word or in here. And I explained that. If you didn't get that explanation, or if you don't understand from open math why it's or, then go back and look at something. What I said, what open math said, whatever works. Okay, 5x minus 3 less or equal to 7. Or 5x minus 3 greater than or equal to -7. So why is that so? For a number to be less than or equal to 7, it can't be a big positive number because that would be bigger than 7, right? And it can't be a big negative number because the absolute value of a big negative number is going to be less than 7. Okay. So we say that as long as what's in here is, I put or there. Yeah, I should put or there. Okay, we'll see in a minute. As long as this number is both less than or equal to 7 and greater than or equal to -7, it's going to work. Any number between -7 and 7 is going to give you an absolute value of 7. There's a way to see that on the graph I'm talking about that. This is an and, where this is an or. Okay, now you solve this. Well, you solve it, you're going to add 3 to both sides, you're going to get 10, you're going to divide by 6. You're going to get x less than or equal to 2. Here, you solve. Now you add 3 to both sides, you're going to get 4. And you're going to get -4. Divide by 5, you're going to get -4. Everybody can do those steps. And it's an and. So now we sketch our number line and put a couple of points on it to correspond to these numbers. -4/5 is less than 2, so it's going to go to the left of 2. There you have it. And now x less than or equal to 2. I didn't do this last time, and I'll say, okay. Here's x less than or equal to 2. Okay, it's all numbers to the left of this, okay? If you just say x less than or equal to 2, you got to have another condition that keeps it bigger than -4/5, right? And x greater than -4/5. -4/5 would be this arrow. It says and. It says it's got to be both. Got to be both. Then it would be here. Is this less than or equal to 2? Yeah, here's 2, which is less than 2, it's less than or equal to 2, right? Is it greater than or equal to -4/5? Well, no, it has to be to the right of 4/5, right? So you got to look. Okay, what about here? Let's say you got 1. Okay, is 1 less than or equal to 2? Yeah, it's greater than or equal to -4/5. So it's both. Okay. Here, this number is less than or equal to 2, but it's not greater than or equal to -4/5. You're not going to shade it. And that's true for all the numbers to the left here. Let me, okay, another brick chalk here. So, okay, all these numbers are less than or equal to 2, but they're not greater than or equal to -4/5, okay? So we're not going to include, now all the numbers over here are greater than or equal to 2, but they're not, sorry, yeah, they're greater than or equal to -4/5, but they're not less than or equal to 2. So we can't include these numbers. In other words, we can include are in here because all these numbers satisfy both conditions. This condition and this condition. Okay? If it was this condition or this condition, any number would work. All right, so anyhow, when we shade it, here is put a whole line. So try to understand the logic of this as best you can because it sharpens your thinking. And it's important. Some things you're going to need to understand later. Okay. Well, that's all I'm going to say about these. If you haven't done this assignment, go to the open math, go to the half credit, you can do it. Okay. That's that needs to be able to do this. And it's not difficult. It boils down to if it's a greater than, it's this or this, it's going to give you 2 intervals. If it's a less than or equal or less than, it's going to give you an and it's going to give you 1. Okay. It's going to give you 2 intervals, this interval and this interval, but it's only when those intervals overlap that you have both conditions. So there's the overlap of these 2 arrows. This is our interval. Okay. We've got left some more room to label. That should get you clarify any questions you might have. Okay. Any questions on it? Just let me know. Otherwise, actually, make sure I'm on the right topic. Okay, everything we've done up till now really is not what we're supposed to be doing in this course. It's elementary algebra. Okay, that everybody comes in the intermediate algebra is supposed to know. But very seldom, even people coming into pre-calculus classes have a good foundation in elementary, much less intermediate algebra. It's intermediate algebra. I mean, you need all the elementary algebra, but you need the intermediate algebra also, at least aspects of it. I've designed this course so that we concentrate on the things that you aren't going to need in pre-calculus. Okay. So now we move into graph. Can you copy down what I just put up here? And don't sit there making 10 marks here, 10 marks here, and so forth. Just use an estimate. Okay, we're a ballpark. Locate the ballpark position each point. 3 marks on the page of everything they are, and then put label the point. So you're going to have the coordinates in the point. Want to make everybody sure everybody's doing at least with the coordinate plane. Okay, now I'm going to go ahead and introduce something that's somehow difficult for my pre-calculus speech. Okay, and it's so. First of all, first coordinate is your x coordinate, right? So your line or your point is going to lie on the line where x equals 7, right? So first of all, where in this graph is, do you know, is a point where x equals 7? Well, it's going to be between 0 and 10. This is x. I didn't play with that because it's implicit, but I wanted to see how much you. Okay. So the x coordinate here is 7, right? Well, we could say, we could go ahead and label a point here. Okay, if we mark this off, 7 would be somewhere around here, closer to 10 than it is to 0, right? I think I got it a little too close, but if we do more than 2, that's about right. Okay, that's plausible for 7, right? Now, if I said 7 was here on the x-axis, no, it's certainly not going to be closer to the y-axis than it is to 10. So I now draw vertical line here, label x equals 7. Okay. Now, a lot of times, and I think it's a terrible idea, in high school classes, people give people a grid to do this on. So you got this thing all lined up, all lined off, and then you put numbers on it. If your numbers aren't all between -10 and 10, you're lost. Okay. You don't think about the numbers, you just do it by rote. I don't think that's a good idea. Okay, but there are certain educators who I presume know some mathematics. We do think so, and they write their textbooks like that. Okay, or they create their materials like that. People kind of constrained to use. So I'm not throwing stones at my friends who use the stupid things that probably don't have a choice. But you have to understand this. Now, does this make sense? X equals 7 here, and it equals 7 for every point above here and below here. Because x is what you get. If you have a point here and you want to find out what the x coordinate is, you make the little dotted line down to the x-axis and read it on. And what point on the x-axis is this above? That's the x coordinate. Okay. And it immediately follows that every point above and below 7 on the x-axis has x coordinate 7. So I can write that out. Might be a little small. I'm just saying every point above or below x equals 7 on the x-axis has x coordinate 7. And all the points above and below line this dotted line. Any point that isn't on this dotted line doesn't have x coordinate 7. You want to get that idea into your head to really understand the coordinate plane. And most of you understood it well enough to put the points out where they ought to be. A couple little mistakes. You might be going back to the y coordinate is negative. You can put a point down here. Okay. But all the rest of the points look good, so I know that was just carelessness. But it's easy to get confused. Okay, well, there it is. Now, where are all the points for y equals 3? copy down what I did here. Don't take time to copy this because we're going to move on. Okay. You know, my statement, you come back and look at it later when I post the video. But what would I do for y equals 3? I did something for x equals 7 here. I drew a dotted line showing all the points where x equals 7, right? Can you draw me a dotted line that shows all the points for y equals 2? Think about that for a minute. I'll write that down. Let's say y equals 2, y equals 3. Where does that go? And make that dotted line and right next to the dotted line, y equals 3. Okay, unfortunately, I didn't record that while I was doing it. Probably would be good, but here's the line giving away, but we first locate 3. Asking, is 3 between -10 and 0? No. Is it between 0 and 10? Yes. If it's not one of those, then is it more than 10? Is it less than -10? Okay. You ask yourself those questions. It's between 0 and 10, and 3 would be about here on a scale from 0 to 10. Okay. And you draw a dotted line. And everywhere on this dotted line, y is 3. So this must be the 0.73. Now we could draw what we call projection line. Draw a line down to here, a line over here, and verify. If the line down to the x-axis lands on 7, then the x-coordinate is 7. If the line drawn horizontally over to the y-axis lands on 3, then the y-coordinate is 3, right? Okay, well that's more than most of you need to say. Make sure everybody's got what they need. Now let's try -4,9. What lines do you need? Start with the dotted line. For x equals -4 and y equals 3. First, you got to want to locate -4 on the x-axis and 3 on the y-axis. Okay. Once you get that, I'll do everything I did for this point, if you can. And then do it for the remaining points. Okay, so the dotted line for x equals -4. First, we locate x equals -4, which would be almost halfway between 0 and -10. If this is halfway, then -4 might be about here. And now here's the line. X equals -4. We label the line. Got to know what these labels mean. And y equals, and I said y equals 3. The point is the -4,9, so I think that's the most, you know, so let's do what I said to do rather than what I said to do. Okay. Y equals 9. So where's y equals 9? Well, it's almost 10. So I'm going to say y equals 9 here. And it's not terribly important right now, whether that's completely accurate or not. It's close enough to tell us about where the point ought to be, right? So now mark the point. -4,9. Now I'm going to clutter up the figure if I draw the rest of these, but having seen that much, you should be able to do these. Okay. And -5, -5 is going to be like about here. This vicinity. And -2, -6, about -2, -6, somewhere around here. And those are drawn without the lines, but I have a vertical line here for x equals 5 It should hit the x-axis halfway between 0 and 10. Okay. In a horizontal line for y equals -5, we should hit the y-axis between 0 and -5. Okay. And similarly here, have a line for x equals -2 and a line for y equals -6. And actually, that point should be a little lower than this one. So I'm gonna put there it is. Okay, somewhere around there. So you have a point in each quadrant. Now, you should know what quadrants are. If you don't, Open Math will explain it to you. But the axes break the plane into 4 regions. This region where both x and y are positive. This region where x is negative and y is positive. This region where x and y are both negative. And this region where x is positive, y is negative. Okay, that's the first, second, third, fourth quadrant. You'll get used to that. Open Math. Make sure of that. Okay. Here's a straight line. Gonna go graph -10 to 10. Your line doesn't have to look exactly like mine, but make it sort of reasonably similar. Best you can. Okay. Now there are 2 really important points on this line. They're called the intercepts. So you have the x intercept here. And the y-intercept here. Can you estimate the coordinates? Each intercept and label both intercepts. The coordinates. Okay. So now according to what I see, this point's about halfway between here and here. And I'm going to actually go ahead and draw the line x equals -5. Okay. Now, if you think it's -7, if you think it's -4, okay, that's fine. The way you drew it, that might be right. As I said, I didn't expect a carbon copy of what I had. So in my graph, x is -5 at this. And of course, we could write a -5 down there in the x scale. And up here, y is about 3 or 4. Okay, so I'm going to say y equals 3. Okay. Now, most of you, and I asked you to estimate the coordinates of each intercept and label. You have 2 intercepts. Here's the x-intercept, here's the y-intercept, right? Most of you, half of you, and that's about right. That's about what usually happens. Post something like this. Okay. People will naturally do what we just did a minute ago. And list the coordinates as -5, 3. Well, -5, 3 is good coordinate corresponds to these lines. So you're thinking. Okay. Is that the x-intercept? No. Is this point the y-intercept? No, the y-intercept is this point. The x-intercept is this point, not this point. Okay. So actually, this point doesn't have anything at all to do with this line. Okay, how many I can advance something? Going to be contrived. Doesn't have anything important to do with this line. All right. So that's not bad, because again, that's exactly what we're doing a minute ago. Okay. So you fell into that. But think about the actual question was asked. Okay, the x-intercept. Now, x-intercept x equals -5. What's y equal? Nobody's the favorite. What's y equal at this point? That's x is -5. Y equals -5 would be down here, right? Okay. And y coordinate at this point is not 3 either. Y coordinate at this point is 3. What's the y coordinate at this point? Okay. Got at least 3 votes for 0, and that's right. The y coordinate here is 0. You're on the y-axis. You see it. Okay. And as long as you see it now, that's fine. Even if you were missing it, because it's hard to focus yourself on exactly what it is it's being said. Okay. And also on the coordinate plane, because most of the class will be pretty rusty with the coordinate plane and not really understand it very well at this stage. Okay. So I'm trying to develop a good rigorous understanding without pushing your brain too hard. Okay. So we have -5, 0. -5, 0. Now, it would be helpful if you understood then, where's the line y equals 0? Well, y is 0 everywhere on the x-axis, because that's what the y coordinate would be, right? 0. -10's here, 10's here, 0's here. So the x-axis itself is for y equals 0. Okay. Similarly, the y-axis is where x equals 0. Help you focus on that and really understand it. It can eliminate a lot of confusion. Comes up later, because there are some things here that are just confusing because it's easy to turn them around. See what I mean? Y-intercept but I'll see if you write down what the y-intercept is. Okay, so the y-intercept, well, the y-coordinate is 3. And it's on the line x equals 0. That's the y-axis. Everywhere on the y-axis, x is 0. Right between -10 and 10. So the y-intercept is 0, 3. Okay. Now the subject, there are 2 assignments to do this weekend. One is just kind of plotting points and plane and do stuff, right? And the other is labeled intercepts. Okay, those are the intercepts. Any straight line has an x-intercept and a y-intercept. And unless the line goes through the origin, the 0, 0 point, it has 2 intercepts, right? If it goes through the origin, it's only got 1 intercept. The x-intercept and the y-intercept, both 0, 0. That makes sense. Okay. I want to do one more thing. And actually, now I'm going to introduce a concept that you might already be aware of. So maybe I'm not introducing it to you just in case. I want to make sure that everybody understands it. It's the idea of slope. If you've got an applied calculus course, for example, in your curriculum, it's the most fundamental concept in first semester calculus. We're not going to do calculus. Big stretch. You gotta get through pre-calculus before you're ready to do calculus. And hopefully, if you do a good pre-calculus course, you'll be ready for that if you need. Okay, so anyhow, I'm going to make an enlarged picture of this graph intercepts. Here's the x-axis, here's the y-axis. Here's the line, x equals what? See what I mean? It's easy to turn this around. Write something down and up and through. And x equals. Do it again. Y is 3. And this line is x equals -4. So that this point is -4, 0. This point is 0. Okay, now we're going to imagine moving from this point to this point. But along the path, it can only go along the horizontal line or vertical line. Okay? So I have to go around each because horizontal and vertical points. So we've either got to go this way and then this way to get to the point, or we could go this way and then this way. Does that make sense? So sketch that point. Just sketch it. They don't even bother to label it right now. Just sketch it through a picture of this and show me your path. You use an arrow, to show me the direction you're moving along the path. Couple of arrows. All right. I'm going to do there are 2 ways to do it using a single horizontal line and a single vertical line. I did say a single horizontal line and a single vertical line. And somebody did something very interesting, which is what we're talking about. Okay. Well, there's one path, right? But there's another way to draw the path. Some people do it one way, some people do it the other. You could go vertical, then horizontal, right? So you got the blue path or the green path. Each works just fine. And if you're drawing this on a graph, you usually choose one that's going to be easiest for you to label. Okay. Okay, so I'm going to use the blue path because I already labeled this way. Okay, so they use a triangle up here. There's a triangle. Okay. So I'm going to make the triangle. Now, how far do I have to rise the vertical line? How far do I have to run along the horizontal line? Okay. So the rise is how long this vertical line is, and the run is right now how long the horizontal line is. Okay. Now, if the horizontal line was going this way, the run would be negative. Okay. The vertical line was going down, the rise would be negative. But right now they're both positive, so we can just say how far. Okay. Do 2 paths, this one or this one. I've chosen this one. I've asked you, what's the rise? Okay. How far you have to go from here to here? The answer is the same as the answer here to here. From here, you go line y equals 0, y equals 3. This line has a length of 3. Okay. This arrow has a length of 4. It goes from x equals -4 to x equals 0. So your run is 4. Your run is the horizontal. Your rise is the vertical. Okay. Rise is 3. Okay. In terms of the words rise and run, can you tell me what slope is? Okay. So unless I haven't heard the words rise and run, they're not familiar to you. But that's what slope is. One quick comment. Okay. There's a formula that they give you that you can do without understanding anything. Except how to plug numbers into a formula, and you get the right answers. You're not gonna understand slope unless you think in terms of this picture and rise and run. Then you understand the formula. You're not gonna understand, you don't have to understand the picture to understand the formula. I mean, to use the formula, okay? So you don't have to understand what slope is to use a formula for slope. You want to understand the picture so you understand what the formula is telling you. So as you work through this, try to keep that in mind, okay? Okay, well, we're about 4 minutes over time. I do apologize. Wanted to wrap that up.